Fractions can look awkward when their denominators disagree, but the real problem is not the numbers. It is the size of the pieces. So keep this four-step rhythm in mind. Match. Multiply when needed. Count. Then simplify. Here is the opening question. How can 1/3 and 1/4 be added when 1/3 and 1/4 are different size parts? Give both fractions the same denominator. Using twelfths keeps each amount unchanged while making the pieces directly comparable. That is the idea behind the entire method. Make the pieces match before you count them. There is a tempting mistake here. 1/3 plus 1/4 is not 2/7. The numerator tells us how many parts we have. The denominator tells us the size of those parts. 1/3 and 1/4 are not the same size, so their denominators cannot simply be added. Match the denominator first. Only then should the numerators be combined. Let the multiples settle the question. For 3, we have 3, 6, 9 and 12. For 4, we have 4, 8 and 12. The first common multiple is 12. Now keep both amounts fixed and rewrite both fractions in twelfths. 1/3 becomes 4/12. 1/4 becomes 3/12. The pieces now match so the counts can be combined. 4/12 plus 3/12 gives 7/12. This next calculation needs almost no setup. 5/8 plus 2/8, both fractions are already measured in eighths. 5 pieces join 2 more pieces, giving 7/8. Now reverse the operation. 7/10 minus 3/10. The 3/10 being subtracted cancel 3 matching tenths from the 7/10. That leaves 4/10. Pair those tenths together, and 4/10 becomes 2/5. Nothing has been lost or added. The same amount is simply grouped more efficiently. Here is the method that saves time. 3/4 plus 2/5. Take the denominator 5 from the second fraction and apply it to the numerator and denominator of 3/4. 3 times 5 is 15. 4 times 5 is 20. Then take the denominator 4 from the first fraction and apply it to the numerator and denominator of 2/5. 2 times 4 is 8. 5 times 4 is 20. The calculation is now 15 over 20 plus 8 over 20. 5 of the 8 extra 20ths complete the first whole, leaving 3 20ths. Altogether, that is 23 over 20. 20 over 20 makes one whole, with 3 20ths remaining. So the answer is 1 and 3 20ths. Subtraction uses exactly the same scaling method. Take 11/12 minus 1/3. Apply the denominator 3 to the numerator and denominator of 11/12. 11 times 3 is 33. 12 times 3 is 36. Then apply the denominator 12 to the numerator and denominator of 1/3. 1 times 12 is 12. 3 times 12 is 36. So we have 33 over 36 minus 12 over 36. 36 is not the smallest denominator available, but it is guaranteed to work. The 12 parts being subtracted cancel 12 matching parts. 21 over 36 remain. Group those parts in threes, and the fraction simplifies to 7/12. This time, get ahead of me. 2/3 plus 3/8. Which denominator should be applied to each fraction? Take a moment and decide. Eight scales the first fraction and 3 scales the second. That gives 16 over 24 plus 9 over 24. Together they make 25 over 24. 24 over 24 makes one whole, with 1/24 remaining. So the answer is 1 and 1/24. The next answer will also pass one whole, and that is completely valid. 5/6 plus 2/3. Using the same pattern, the fractions become 15 over 18 and 12 over 18. Their total is 27 over 18. 18 over 18 makes one whole. with 9 over 18 remaining. That simplifies to 3/2, or 1 1/2. An improper fraction is not an error. It simply represents more than one whole. Whole numbers now join the calculation. 2 3/4 plus 1 2/5. Separate the whole number parts from the fractional parts. 2 wholes and 1 whole already make 3 wholes. For the fractional parts, 3/4 becomes 15 over 20, and 2/5 becomes 8 over 20. 5 of those 8/20ths fill the remaining 5/20ths, completing another whole. 3/20ths are left. The 3 original wholes, together with the newly completed whole, make 4 wholes. So the result is 4 3/20ths. Mixed number subtraction adds one important question. Is there enough in the fractional part to subtract what we need? Take 4 1/6 minus 2 3/4. First, match the fractional parts. 1/6 becomes 4 over 24. 3/4 becomes 18 over 24. 4 over 24 is not enough to subtract 18 over 24, so regroup one whole from the first mixed number. 4 4 over 24 becomes 3, and 28 over 24. Now subtract in a clear order. The 2 whole units being subtracted cancel 2 whole units. Then 18 over 24 cancel 18 matching parts. 6/24ths remain from the regrouped whole. The original 4/24ths join those 6 parts, making 10 over 24. 1 whole remains alongside them, so we have 1 and 10 over 24. Group the fractional parts in pairs. 10 over 24 simplifies to 5/12ths. The final answer is 1 and 5/12ths. Before another full problem, isolate the simplification step. 6/9 can be regrouped into thirds. 6/9 is equal to 2/3. The amount stays exactly the same, only the number of groups changes. Try the same idea with 10 over 24. Group the parts in pairs. 10 over 24 becomes 5/12ths. Now put the full subtraction method together. 3 1/5 minus 1 3/4. Choose the denominator from the other fraction. Take a moment. The fractional parts become 4 over 20 and 15 over 20. There is not enough in 4 over 20, so regroup one whole. 3 4 over 20 becomes 2 24 over 20. The 1 whole being subtracted cancels 1 whole. Then 15 over 20 cancel 15 matching parts. 5/20ths remain from the regrouped whole. Add the original 4/20ths, and the fractional part becomes 9/20ths. 1 whole remains, so the answer is 1 and 9/20ths. Next, connect the equivalent fractions to equal parts of 1 whole. Take 5/8 plus 1/4. Apply the opposite denominators. 5/8 becomes 20 over 32. 1/4 becomes 8 over 32. So the sum is 28 over 32. Think of the whole as 32 equal squares. 20 parts come from 5/8. 8 more come from 1/4. That gives 28 filled parts out of 32. Now group the parts in sets of 4. 28 divided by 4 is 7. 32 divided by 4 is 8. So 28 over 32 simplifies to 7/8. Therefore, 5/8 plus 1/4 is 7/8. Before the last question, fix the rule in place. Suppose the first fraction is I over b, and the second is c over d. Multiply the numerator and denominator of the first fraction by d. Multiply the numerator and denominator of the second fraction by b. Then combine the numerators, keep the common denominator, and simplify if possible. Final question. 2/7 plus 1/3. Use the same method and try to stay one step ahead. Take a moment. 3 scales 2/7 giving 6/21, 7 scales 1/3 giving 7/21. Now the denominators match. 6/21 plus 7/21 gives 13/21. Think of the whole as 21 equal parts. 13 of those parts are included. 13 and 21 have no common factor greater than 1. So 13/21 is already in its simplest form. The method is now yours. Match the pieces, multiply when needed, count carefully, then simplify.